In this question, we've got some calculus and some graphs, and it's a very typical exam 1 question. It would be about the right level of challenge for you. So let's have a go at this and see what we can find out. We've got a tangent to a graph of y equals log x, natural log x, base e, which has an equation. The tangent has the equation y equals mx, where m is a real constant. Firstly, we have to find the value of m, and secondly, we have to find the x-intercept of the normal to the graph of y equals log x base e at the point where the tangent referred to above intersects it. Now guys, that's a bit of a mouthful, isn't it? I think the very first thing I would do is I would sketch a little graph to see whether I can visualize what's happening here. Okay, there's a graph, y equals log x base e, and I've got a tangent to that graph, y equals mx. And you'll notice y equals mx means that this little tangent goes right back through the origin. Okay? Now, if you look at this, I think that we have got this situation uniquely constrained so that it's pretty clear that there's only one line possible here, which would be a tangent to a log x graph which would go through the origin. So we should be able to use the information that we've been given to zero in exactly on what the equation of this line is, and more specifically what the value of m is. So let's get a game plan happening here. We need the equation of a straight line. We need the gradient of the straight line, which will come from this function here. We can do the gradient of a log x graph, and then we can go ahead, we can call this intersection point here something or other, for example a and log a, and then we can set up the equation of a straight line, can't we? Yes, and then we can manipulate that equation of the straight line so that there is no y-intercept and see what happens. I think that's enough of a game plan for now, and let's just go with that and see where we go. I'm sure we'll go somewhere pretty good, and if it isn't exactly what we want, we will then see the way forward to get exactly what we want. Okay, let the point of intersection of the tangent with the graph of y equals log x base e be a and log of a. There it is on the graph, alright? A and log a. Now, let's proceed a little bit further. If y equals log x, what is the derivative of that? It is 1 over x. Yes, that is the gradient function for y equals log x base e. Now, the gradient at x equals a, seeing that we've chosen a for that point of intersection, would be 1 over a. Okay, so that's the specific gradient at the point of intersection. Alright, so we've got our gradient now. Hence, the equation of a straight line tangent intersecting at a and log a would be of this form. Y equals m, in this case 1 over a, x plus c. Now, why don't we substitute our value of x in here and our value of y in here, which we've got here, and then see where that takes us. Okay, here we go. Da-da-da-da, that looks pretty interesting, doesn't it? So log of a equals 1 plus c. Now, guys, you know and I know that c in this case is 0. So why don't we just use that information by setting c equal to 0 and see where that takes us. So we've got log of a base e is 1, which then, guys, that is the answer we need, because we therefore know that a must be what? E. A must be e. So that's very, very fascinating. The point of intersection of the tangent with the log graph, such that it goes through the origin, must be such that a is the value e itself. So this point here is now e log of e, which will be a and 1. Yes? Get that? Alright, let's go over the page. So, following on from what we were just doing there on the previous screen, y is now 1 over a times x, that is the tangent line, and if a equals e, which we've just discovered that it is, we've got y equals 1 over e times x, and therefore what is m? We saw in the description of the question that y equals mx, but y equals 1 over ex, and therefore m is 1 over e. Okay? Very simple if you just set yourself up a game plan and just follow through and don't get flustered. Alright, we've got to find the x-intercept of the normal to the graph of y equals log x at that intersection point, which we've just been playing with, and we've got to find the x-intercept of the normal. Alright, let's go with that. Now, same procedure guys, same procedure, exactly the same procedure. Find the equation for the normal based on the information that we've got, and then set y equal to 0 to get your x-intercept. Very simple, just keep your head and keep going. So if m of the tangent is 1 over e, then m of the normal is going to be the reciprocal, the negative reciprocal of that number, which is minus e over 1. Okay, so now we've got the gradient of our normal. We know the intersection point, don't we? It's e and 1, isn't it? Yes. So therefore, we've got the equation of the normal would be in general form y equals minus ex plus c. We're going to substitute the point in e and 1, and we're going to get, therefore, 1 is minus e times e plus c. Okay? So just cleaning that up a little bit, we've got 1 equals minus e squared plus c. Therefore, what is c? c is 1 plus e squared. Therefore, the equation of our normal, guys, is y equals minus ex plus 1 plus e squared. We're very close to victory now, guys. We've just got to set y equals 0 for the x-intercept, okay? So there it goes, and we've got that, and then we just solve that for x, okay? So let's do that. X looks like being, that's correct, isn't it? Yes, 1 plus e squared over e. So the intercept, the x-intercept of the normal is the point, as we see there. 1 plus e squared over e is the x coordinate and 0 is the y coordinate. Put a box around it and give yourself a pat on the back and get out of there and go on to the next question. Alright, I hope you got something out of that. All the very best, and we'll see you soon.